CCNA version 7 ITN skills assessment. Introduction to networks. This topology router Cisco 4221. I will use 4321. Okay, the name is TTC router. Cisco 2960 for the switch. 2960 SW1 PCA and PCB. PC-A, PC-B, and gigabit 000 to PCB, gigabit 001 to fast Ethernet 5 on the switch, fast Ethernet 06 to PCA. Okay, very good. Develop an IP addressing scheme. Okay, this is the IP address, the base IP address. This is the number of hosts for subnet A, and this is the number of hosts for subnet B. Okay, and subnet A is the subnet for PCA. And subnet B is the subnet for PCB. Subnet A and subnet B. Okay, for subnet A, 100 hosts, and subnet B, 50 hosts. Okay. Okay, and use this file. Okay, this file. The base IP address is this. One 45, 25, 35, 0. Okay, here on the base IP address should be a prefix. Okay, a prefix. I will use 24. Okay. This is necessary for some calculations. Not important, but I will use 24. Okay. 24. Okay, and for subnet A, 100 of hosts, subnet B 50 hosts. Okay, the first two octets in decimal. Okay, the first two octets of the base IP address in decimal 145, 25, and the third octet 35 in binary here, in binary. Okay, 35 is 0, 0. This is 32. Okay, this number is 35 in binary. 32 plus 2 plus 1, 35. Okay. And the fourth octet, 0 in binary, is 0, 0, 0, 0, 0, 0. Okay, very nice. This is the base IP address in binary. So you need, for subnet A, start with the highest number of hosts. Okay, start with 100. Okay, and you need 100 of hosts, and here host 126 is very good for 100 of hosts. Okay, so the subnet mask should be this. Okay, 126 is a very good number to support 100 hosts, and the subnet mask is this. So this is the network address in decimal: 145.25, 145.25, 35, okay, in decimal, 35, and 0. And the prefix is this, 8 bits plus 8 bits, 16 bits, 17, 18, 19, 20, 21, 22, 23, 24, 25. Prefix 25. Okay, and copy this, okay, and the remaining spaces fill with ones. 1, 1, 1. Okay, and this is the broadcast address: 145.25, 35, 45.25, 35. This number is 127. Okay, 127. And the prefix is the same, 25. The prefix is the same, 25. Now, the first IP host, the first usable IP host, is one next to the network. If network is 0, the first IP host will be 1, 145, 35, 35, 1, same prefix. And last IP host, last usable IP host is 1 before the broadcast. If broadcast is 127, last will be 126, 145, 25, 35, 126, prefix 25. Okay, very nice. Okay, and subnet B. Okay, find the or calculate the next number of this. Okay, the next number in binary of this. 145, 25. Okay, 1 0 0 0 1 1. Okay, if you have 7 ones, if you have 7 ones, the next number is 1 followed by 7 zeros. Okay, if you have 7 ones, the next number in binary is 1 followed by 7 zeros. Okay, so this number is the next subnet, and you need 50 hosts. Okay, here on host 50, 62 is a very good number that supports 50 hosts. Okay, this is very good. So the subnet mask or prefix is this. Okay, and this is the network address: 145, 25, 35, 145, 25, 35. This number is 128. Okay, and the prefix is 8 bits plus 8 bits, 16 bits plus 8 bits, 24 bits, 25, 26. 26. Okay, this is the network address, and copy this section and fill the remaining spaces with 1, 1, 1, 1, 1. Okay, and this number is the broadcast address. Okay, 145, 25, 35. This number is 128 plus 63. Okay, is 191. 191. Same prefix is 26. Okay, remember 128 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. 128 plus 63. 191. Okay, so the first usable IP host is one next to the network: 145, 25, 35, 129, same prefix. And last IP host is one before the broadcast. Okay, 190, same prefix, and that's it. Okay, this is these are the subnets. Okay. Okay, new IP mask in decimal for subnet A. Okay, for subnet A, the prefix is 25. 25 in decimal is the following: 255, 255, 255, 128. Okay. Okay. But this in binary is the following. Okay, is this? So that's why you have 25 ones. 8 plus 8, 16 plus 8, 24 plus 1, 25. So that's why the prefix is 25. And in decimal is this. Okay, for subnet B, it's 26 in decimal. Is this? Okay. Okay, in binary, okay, 26 ones and 6 zeros. So that's why the prefix is 26. Very good. And number of bits in the subnet, only count the number of zeros, 7 zeros, here 6 zeros, okay. Maximum number of usable subnets, including the zero subnet. Okay, do the following. And the new prefix for subnet A is 25. 25 minus the prefix of the base IP address, 24. This is 1. Okay, and 2 to the first. This is 2. Okay, so the answer here is 2. Okay, now here the new prefix is for subnet B, the new prefix is 26. 26 minus the prefix of the base IP address, 24. This is 2. And 2 to the second, the answer is 4. Okay. Number of usable hosts per subnet. Just count the number of zeros here. 7. So 2 to the 7th minus 2. 2 to the 7th is 128 minus 2, 126. Okay, here count the number of zeros. 6, 2 to the 6th minus 2. 2 to the 6th is 64 minus 2 is 62. Okay, very good. The IP subnet, this is the network address, is this. For subnet B, the network address first IP host, last IP host. For subnet B, first and last. Okay, this table is completed, and assign the first IPv4 address to each subnet to a router interface. Okay, the first IP address for the router interfaces. Okay, for interfaces on router, use the first IP in the subnet. The last for the PC, the last IP address, the last usable IP address of the subnet for the PC, and the second IPv4 address of subnet to switch 1. Okay. First IP address, last IP address. Okay, is this? Maximum number of hosts is this. Okay, remember PCA is placed on subnet A. So for PCA, use the last IP address in the subnet. In the subnet, the last IP address. Use this. And the subnet mask, you know, is the prefix is 25, but use the decimal notation. Okay. For gigabit 000 on the router, gigabit 000 is placed on subnet B, and for this interface, use the first subnet B, the first IP address. The prefix is 26, but on decimal is this 192. Gigabit 001. This is gigabit 001 placed on subnet A, so use the first IP for on subnet A, first IP address, and 25 is this in decimal, 128. For the switch, use the second. The switch is placed on subnet A. Use the second IP address. Okay, gigabit 001 is placed on subnet A. Gigabit 001 placed on subnet A. For the switch, the second IP address on subnet A and will be, if the first is 1, the second will be 2. On subnet A, the prefix is 25, and is this in decimal 128. Okay. 25 prefix in decimal is this 255, 255, 255, 128. And for PCB, use the last IP, but last IP on subnet B, and subnet B last IP. And you know the prefix is 26, that is this in decimal 192. Very nice. Okay, and for IPv6, this is the base IP address. Okay, and okay, use this IPv6 address, okay, this, and create two subnets. Okay, and you have this IPv6 address. IPv6 address has 8 sections. Okay, first section, second section, third section, and fourth section. The fourth section is used for the subnets. So the number of subnets should be placed here. For example, in the fourth section, number 1 will be the first subnet, number 2 will be the second subnet, number 3 the third subnet, and so on. Okay, but I think only for practice, not on real life, only for practice, you need to add the fifth section, something like this. Okay, for example, in the fifth section, add the number A, and column, and add a prefix to cover 5 sections. Each section has 16 bits. So for 5 sections, 16 times 5 is 80. Okay, and here you can add, okay, B with prefix 80, only for practice. Okay, the A subnet will be placed for the interface on the router. Place it on subnet A. The interface on the router on subnet A is gigabit 001. And for subnet B, gigabit 000. Okay, and prefix length 80. Okay, this prefix. Okay, very nice. And use FE80::1 as the link local address for both router interfaces. Okay, no problem. Gigabit 000. Okay, gigabit 000. This is the IP address, the IPv6 address. but I will use the first IP. On IPv6, the first IP is 0. Okay, because you can use 0 as the first usable IP address only on IPv6. But anyway, to not confuse this practice, I will use 1. The prefix is 80. Okay. Okay, for gigabit 001, use this. I will use the first is 0, but I will use 1. The prefix 80. And for switch 1, the second, switch 1 is placed on subnet A. So use the second IP address. That in this case will be 2, prefix 80. And the gateway for this switch will be for this switch, the gateway is the default gateway is the IP address of gigabit 001. Gigabit 001. This IP. Okay, you can use the global unicast address. Or you can use the global unicast address, or use the link local address FE80:1. Okay. Okay, configure the router. Command line interface. Would you like to enter initial configuration dialog? No. Enter. Okay, enable configure terminal. Disable DNS lookup. No IP domain lookup. Router name. Use this. Host name. TTC router. Enter. Okay. Underscore. Okay. Domain name. IP domain name. Domain-name CCNAv7.com. Okay, privilege encrypt, privilege exec password, Cisco MPass. Okay, enable secret, Cisco MPass. Okay, be careful with passwords. Console access password, Cisco Compass. First enter to line console 0, because there is only one line, only one console, is number 0. Password, Cisco Compass. Be careful and log in to enable the access. Enter. Set the minimum length for passwords 10 characters. Okay, exit from the line console. Okay, now you are on global configuration again, and set the minimum length of passwords. Security passwords min length 10. create administrative user and local database. Okay, username. Okay, and username admin. Secret password admin one pass. Be careful. Admin one pass. Enter. Set login on VTY lines to use local database. Okay, enter to VTY lines. Line VTY from 0 to 15. You will have 16 possible connections from 0 to 15. Okay, enter. Login to VTY lines to use local database. Login local. Okay, to use this username and password. Okay, login local to use this username and password, and accept SSH connections on VTY lines. Transport input SSH. Okay, very good. And exit. Okay, now you are again on global configuration modes. Okay, encrypt clear text passwords. Service password dash encryption. Configure a message of the day banner. Banner message of the day. And use 2 characters, and between the characters use a message. Unauthorized access is prohibited. Okay, this is the command. Okay, this is the message. Okay, if you will open with this character, close with the same character. Unauthorized access is prohibited. Enter. Okay, and enable IPv6 routing. IPv6 unicast dash routing. Configure interface gigabit 000. Interface gigabit 000. Okay, set the description. You can use any description. For example, gigabit 000 is placed on subnet B. You can use that. Subnet B description. This is only a text informational text. Okay, don't worry about this. This is not a configuration. IPv4 address, IP address, and remember and use this 145, 25, 35, 129. Subnet mask. Okay, very nice. Now, IPv6 link local, IPv6 address, FE80::1, link local. Okay. IPv6 address, global unicast address. Use this. Okay, this is the subnet. The network address, use this, the host IP address. gigabit 000. IPv6 address 2001 145 25 1 B colon 1 prefix 80. Okay, use this. Enter. Activate the interface. No, shut down. Okay, now. Okay, gigabit 001. Gigabit 001. Description. Subnet A, for example. Gigabit 001 on subnet A, very nice. IPv4 address is 1 subnet mask 128 128. Okay, enter. IPv6 link local address FEA0 ::1 FEA0 ::1 link local IPv6 address is A ::1 prefix 80. Okay, A ::1 prefix 80. Okay, enter. Enable the interface. No shutdown. Very nice. Generate an RSA crypto key, 1024 bits for modulus. Exit from interface configuration mode. So you are now on global configuration mode. Crypto key generate RSA general keys modulus 1024. Enter. Okay, very good. Okay, and now configure the switch. Access the switch. Command line interface. Enter, enable, configure terminal. Disable DNS lookup, no IP domain lookup. Switch name SW1, host name SW1, domain name IP domain -name CCNAv7.lab.com. Encrypt privilege exit password Cisco and pass. Enable Cisco and pass. Be careful. Console password Cisco compass. First access to line console 0. Password Cisco compass. Be careful. And don't forget to use login to enable the access. Exit. Shut down all unused interfaces. Okay, you are using 5 and 6, so disable any other interface from 1 to 4, from 7 to 24, and gigabit 1 and 2. Interface range fast Ethernet 1 to 4, comma 5 and 6 in use, so from 7 to 24, gigabit 0, 1 and 2. Enter. shut down, enter. Okay, very nice. Create username and password, exit, global configuration mode, username, admin, secret password, admin, one pass. Be careful. BTY lines to use the local database for username and password. Line BTY 0 to 15. Login local. Okay. SSH connections on BTY lines. Transport input SSH. Encrypt the clear text passwords. Okay. Exit from line configuration mode. Global configuration mode. Service password dash encryption. Enter. Configure message of the day banner. Banner message of the day. Use a character between the characters. Set the message. Unauthorized access is prohibited. Unauthorized access is prohibited. Enter. Generate RSA crypto key 1024 bits. Crypto key generate RSA general keys modulus 1024. Enter. Okay, very good. Configure management interface SBI on VLAN 1. Okay, and interface VLAN 1. Set the description. For example, subnet A. IPv4 address. For switch is this, use this, and subnet mask. IP address 145.25.35.2. 255, 255, 255, 128, and IPv6 link local address FE80::2. IPv6 address FE80::2. Link local. Okay, invalid input detected. Okay, and okay, do the following to support IPv6. First, save changes. Copy running config to startup config. Okay, enter. Okay, save changes, then configure terminal. SDM prefer question mark, and use this dual IPv4 and IPv6. Dual IPv4 and tab. Default. Enter. Okay, but reload. Okay, to take effect. Okay, and reload. System configuration has been modified. Save yes. Enter. Okay, password. This is the console password. Cisco Compass. Cisco Compass. Now enable the enable password. Cisco MPass. Cisco MPass. Okay, verify with show running config. Space. Interface VLAN 1 is configured with description, IP address, IPv4 address. Now complete with IPv6 configure terminal and interface VLAN 1, IPv6 address, FE80::2, link local, very nice, and IPv6 address, global unicast, and is this, okay, IPv6 address 2001 145:25:1:8:2 prefix 80. Okay, verify, be careful, and very nice, enter. And obviously enable the interface. No, shut down. Okay, exit. Now configure computers. Okay, this is the IP address for computer and subnet mask. Okay, this is for PCA. Subnet mask is this for PCA. Default gateway for PCA. The default gateway is the IP address of gigabit 001. Gigabit 001 is this. Physical address and IPv6 address. Okay, PCA is placed on subnet A. Okay, this subnet. Okay, subnet A on gigabit 001. Gigabit 001. This subnet. Okay, let add for example A. Okay, for the PC will be A. And the IPv6 default gateway is the IPv6 address of gigabit 001. IPv6 address of gigabit 001. Okay. Or use the link local address, the IPv6 link local address. Okay, or use FE80:1. Okay, you can choose any. Okay, for PCB, this IP and this subnet mask. This IP, you know, the subnet mask is 192. The default gateway of PCB, IP address of gigabit 000 on router. Okay, and gigabit 000 on router. IPv6 address. PCB is placed on subnet B. Okay. Gigabit 000. Okay. Gigabit 000 is subnet B is this. Okay, but use IP host, IPv6 for host. You can use B, for example. And you know the IPv6 address for the default gateway for IPv6 is the IPv6 address of gigabit 000 on the router. Okay, gigabit 000 on the router is this. Or use the link local address. Okay. But configure the PCs. Okay, PCA. Desktop, command prompt. If you want to verify the physical address, use ipconfig/all. This is the physical address or MAC address. Okay. Okay. The description, you know, is something like PCA or something like this. IP configuration, use this IP. Subnet mask, use this. Default gateway, use this. Okay, for IPv6, use this IPv6 address. Prefix 80. Default gateway, use global unicast or link local. I will use link local. Okay. Very nice. And PCB. IPv4. Subnet mask. Default gateway. IPv6. Prefix 80. Default gateway. Okay, very nice. Verify end-to-end connectivity from PCA. Space ping to gigabit 000 on router ping router gigabit 000. Is this 129 145 25 35 129? Enter. Success. Very nice. It is this IP address. Okay, on IPv6, ping 2001, 145, 25, 1, colon, and gigabit 000 IPv6 address. B colon 1, B colon 1. Very nice. Okay, is this IPv6. Gigabit 001. This IP is 1. Very good. Okay, and IPv6, is A1, A colon 1. Very good. Ping to switch on VLAN 1. The IP address of the switch is this. Very nice. Okay. IPv6, is A colon 2. Very good. PCB IP address is this. Very good. IPv6, is B colon B. Very nice. Okay, go to PCB. Ping to gigabit 000. Okay, and gigabit 001, and switch. Okay, 145, 25, 35, 129. Very nice. IPv6 001, 145, 251 colon B colon 1. Okay, this IPv6 address. Very good. Gigabit 001 is 1. Very good. IPv6 address A colon 1. Very good. Okay. For the switch, use this. Is number 2. Okay, this will fail. Okay. Why? Because you need the default gateway on the switch. Okay, configure the switch, but no default gateway configurations. Configure the default gateway on the switch. Enter console password Cisco compass. Enable password Cisco mpass. Configure terminal IP default gateway. And the IP before address of gigabit 001. Gigabit 001 IP before address is this. One 45, 25, 35, 1. Okay, very nice. So try again on PCB. Try to ping again the switch from PCB to the switch. Okay, very nice. Now is okay. And finally, from PCB ping to the IPv6 address of the switch A colon 2. Okay, this will fail because you need to add the IPv6 default gateway on the switch. Okay, but it's not possible to configure the IPv6 default gateway on this switch because the IPv6 default gateway is learned automatically. Okay, the IPv6 default gateway is learned automatically, and this is not happening on Packet Tracer. This is a limitation on Packet Tracer, but will work on real lab. Okay, or use this switch. Use switch 3650 and create a static route. IPv6 route colon the default route, and use the IPv6 default gateway. Okay, this is a default route, something like configure the default gateway, but this is not the configuration of IPv6 default gateway, but is a IPv6 route using the default gateway to reach other networks. Okay, this is the IPv6 address of gigabit 001. Okay, and try again from PCB ping to the switch, and will work. Okay, very nice and success. Okay, and now appropriate commands to discover the following information. Okay, on the router, console password Cisco compass, enable password Cisco mpass. Okay, show version space router model. Okay, this is the model, Cisco ISR 4321. EOS image, file is this, Bing extension, that Bing, RAM. Okay, physical memory. Okay, use this about 4 gigabytes of memory. Flash, okay, flash memory. About of 3 gigabytes of flash memory. Configuration register is this. Command, this is. Display a summary of important information about IPv4 addresses, interfaces, a summary. Show IP interface brief. Okay. IPv4 routing table. Show IP route. Okay. Layer 2 to layer 3 mapping. Show ARP. Detailed IPv4 information on gigabit 000. Show IP interface gigabit 000. Space. IPv6 routing table. Show IPv6 route. Summary IPv6 interfaces. Show IPv6 interface brief. devices connected to the router. Show CDP neighbors. Sorry, it's neighbors. Okay. Save the current configuration. Copy running config to startup config. Enter. Okay, very nice. Thank you very much.